Don't screw it up.
All right, I'm ready when you are.
Good afternoon, everyone. My name is Billy Hansen, and I go to Lakeview High School.
Good afternoon, everyone. My name is Jacob Nelson. I go to Fresno High School.
And today we're going to be talking to you all about spheres and circles. Now, look at a sewer system, right? When you look at a sewer system, you see a manhole cover on the ground, and wow, look at that. It's round. But why is it round, you may ask? Well, circles are pretty neato. So if I have my lovely volunteer from the audience, Ethan, come up, we'll see that we have our own sewer system. And if Ethan could stay up here and hold this, you'll see that the reason that circles are the manhole covers we use are because circles can't fall through themselves. But when you look at a square, look at that. It falls through itself. No way. Who knew? Let's give a big round of applause for Ethan for doing that for us. So that's why manhole covers are round. So I'm going to hand this over to Jacob.
All right. Well, why does this work, though? Well, the main reason is that the diameter of the cover is 7.25 inches, while the diameter of the manhole is only 6 inches. Also, the circumference of this cover is 14.5 pi inches, while the circumference of the manhole is 12 pi inches.
All right, hold on, Jacob. Slow down. We don't really know what this stuff means, like pi and circumference. What are you talking about,
I
man?
mean, do you have a better way to explain?
Well, lucky for you, I made a whole presentation to do this. Our purpose today is to teach you about the surface area and volume of circles and spheres.
So you mean that by the end of the presentation, they'll know both of these really long and boring standards?
Pretty much.
Okay, so they're going to be able to know the formulas for the area and circumference of circles and use them to solve problems, give an informational derivative of the relations between circumference of area and circle, and know the formulas for the volumes and volumes of circles. You'll know that stuff.
Yes. So, first we're going to teach you some terminology and parts of circles and spheres. So we have a circle, right? When you look at a circle, it has a center point. And if you draw a line that goes from one edge of the circle to the other edge, God bless you, through the center point, we'll have a diameter. And this is the longest line that can be on the inside of the circle. I got a laser. We also have a radius. That protrudes from the center point of the circle to the outside edge. I almost blinded my friend Jacob. We also have the circumference, which is the entire length of the outside of the circle. And we have the radius, which is always going to be half of the diameter, because it only protrudes from one side of the center point, not both sides.
All right, now it's time for pi. And no, it's not this pi. Unfortunately, I do wish we would have brought pi. But whatever. We're talking about this pi, the kind of pi that is irrational. Now, irrational means that is a number, or a decimal to be more exact, that will never stop. It'll keep going and going, and there'll be no repetition. Also, it's usually rounded down to 3.14 unless you're some kind of super genius and know every single digit. And it looks like this. This is the symbol for pi.
So now we're going to talk to you about area. So area of something is just the amount of space that it takes up on a two-dimensional plane, or a flat surface. So to find the area of a circle, you just have to plug the radius into an equation so that you can find it. A equals pi r squared. So area equals pi times r squared. So if you look at the circle, the radius would be r. You'd square it, or multiply it by itself, and then you multiply it by pi to get the area.
So here's a little real-world problem to make sure you understand this. So we have a pizza maker, and we want to know how many calories are there in one slice of pizza if there are 50 calories per square inch. And keeping in mind that this is the formula for the area of the circle, we're given that the pizza has a diameter of 16 inches. Now, who can tell me what the radius would be?
8.
8, good job. All right, so if we plug it into our equation, we get area equals pi times 8 squared, and 8 squared is?
64.
Good. Now, does anyone know what pi times 64 is?
No.
Very good.
No, the answer is 200.96. Now, this is only using 3.14. If you use the actual number for pi, which is obviously infinite, you get a much different number. But it's much easier to just multiply by 3.14. As you can see, it isn't much different from just saying 3.14.
So now, if you see, we still have the rest of the problem to do, because the question was how many calories are in our pizza per square inch. So we have 200.96 square inches. If we multiply by 50 to get the number of calories, we will get that the pizza with diameter of 16 inches has 10,048 calories.
Okay, so now what about surface area? Well, we're going to start with a square because, or a cube, because circles are a little bit harder than spheres. So surface area is just the area of the outside. Now, if we take this cube and we take one face and put a grid over it, and each of these squares is 5 feet, what is the area of this side of me? 25. Good job. Now, how many sides does a cube have? 6. Good job. Okay, 25 times 6 is?
150.
Yes, 150. All right, now we're going to do some serious spheres. Now, spheres are a little bit different because spheres don't have sides. So what you have to do is you have to take the radius, multiply it by itself, or square, multiply it by 4, and then by pi. So if we have our little sphere here, this is our diameter, and this is our radius, and the radius is 5. And we plug this into the equation, we get 4 pi, pi squared. So what is pi squared?
25.
Good job. And then, oh, I'm not sure why they said that. And then does anyone know what, well, let's start here. What's 4 times 25?
100.
So what about 100 times pi?
310.
Something like that, yeah, something along those lines.
Now we're going to talk to you about volume. So volume is just something that takes up space in a three-dimensional plane. Like a 2D plane is the area. Well, if you have a 3D plane, like this box right here, it would be the volume. So, to find the volume of a sphere, it's very interesting because you have to plug it into an equation just like for area and for surface area. It's 4/3 pi r cubed, and you cube it because volume is in a cubic space. So you would take this sphere, and the volume of it would just be the sphere filled up.
Now that's a lot of information to take in, so we're just going to test you again. So in this problem, we have how much water will fit into a fish tank. We've all seen a fish tank, and most of them are usually spheres. So we know that 1 cubic inch of space holds 16.3871 milliliters of water. We also know that the diameter is 12 inches, making the radius 6 inches. Good job. So here again is our formula for the volume of a sphere, and if we plug that in, we get volume equals 4/3 pi 6 cubed. And does anyone know what 6 cubed is?
216. 206.
Right? Yeah. Anyway, does anyone know what 206 times pi is?
No.
I didn't think so.
600.
About 4/3.
About 4/3 times 206.
That would be 824 over 30. Whatever that is.
724, and then if we multiply that by pi, we get 862.89 inches cubed.
Now, we're not yet done with our equation because we still have to plug in the milliliters of water. So we would just multiply that by 16.3871, and we would get 14,140.26 milliliters. That's a little hard to imagine, so we're going to convert it to liters by just dividing it by 1,000, and we get 14.14 liters approximately.
So in conclusion, what did we learn? Well, we learned a lot of stuff. We learned about the circumference, diameter, radius, all these things about circles. We also learned about volume, surface area, and circumferences of spheres. So how can we compare this to the real world? Well, we gave you an example at the beginning with our manhole cover that can not fall in on itself. But what about for spheres? Well, there are many examples of spheres in this world. Now, unfortunately, there isn't such thing as a perfect sphere, because no one is perfect. But spheres can be found in fish bowls, or just bouncy balls, or ball bearings, just things of that nature. And why does this even matter? Because there's just a lot of uses for spheres. Bowling balls, fish tanks, pretty much anything that holds things is a sphere.
Most things, at least.
Most things.
So that wraps it up for us. Any questions? Nick?
So why to find the volume of a sphere? Why would you multiply by 4/3? Like, is there a special reason for
Yeah, because like I
that?
said,
An old dead dude came up with that.
The area of a sphere, or I'm sorry, the area of a circle, say radius 6, I believe that's what we had, I don't remember what it was, but the area of that would be 6